So in part 5, we're going to start talking about random variables. And our random variables, the most important thing here is that they are numeric outcomes. So we're looking at basically quantitative variables that are random in terms of what occurs, unlike our quantitative variables that we saw when we were collecting data. So we have some examples here. Tossing a coin and recording the number of heads. You can see here we have a lot of number things where we're counting up. So a lot of stuff with counts. We also have other variables here where we have like scores or height. And all of these can fall into one of two categories, either discrete or continuous. So our discrete random variables take our isolated points, as we saw this back in part 2. So these first 3 examples are all discrete. Because in this case, if we're talking about a count or a number of things, you can only have 0, 1, 2, and then the first example up to 10. The next one about approval of the president, again, if we're only asking 100 people, we could have 0, 1, 2, all the way up to all the people responding that they approve. And then the number of items on an assembly line before the first defective one, again, oops, not 0, that doesn't make sense, but 1, 2, 3, and this one doesn't necessarily have a set number, right? This could keep going kind of forever, but all of these are discrete because there's no, you can't have 1.5 defective items or items looked at before you reach a defective one. Versus the last 2 here, which are scores and height, these are continuous. And now scores obviously could be thought of as discrete, because at some point I don't do any division of my stuff down past like half points. So scores is questionable, right? You could have 0. We saw some people got like a 69.5, 70. Technically, nobody's going to get a 70.2 because I don't give out points in that matter. So if you think of it this way, this is really more discrete. They don't have to be whole numbers. And the only one that's truly continuous is the height of San Diegans. But again, depends on how you're reporting that out. So, and its most pure way, it is a continuous random variable. So we're going to start part 5 looking at discrete random variables because they're a little bit simpler. We can write out every possible value and see what the probabilities of each occurring are. So our sum of 2 dice, remember we had a bunch of events that fell into that situation, but we're now looking at this as a random variable. So every possible outcome when you're talking about the sum of 2 dice can be written down. We have 2 up to 12, and then you can write down all the probabilities of them as well. In order for a discrete probability distribution to be legitimate, everything has to sum up to 1. So you must have every possible outcome because your x, your random variable, basically represents the entire sample space, and each of the probabilities individually has to be a legitimate probability between 0 and 1. So one of the things I might ask you to do on the exam and just in general is to create this probability distribution. So we have this first exercise here. We have a bag containing red and blue marbles. Already, hopefully, we're starting to feel like this reminds us of our sampling without replacement. So we have 3 red marbles and 8 blue marbles. And then we are going to select 2 marbles without replacement. So there's our little pat on the back that we are indeed doing sampling without replacement. Now x is going to be the number of red marbles selected. And we're going to create a probability distribution. So if you're going to create a probability distribution, there are essentially 2 pieces. Step 1, you need to determine values for x. Right? What are the different number of red marbles we can end up with? So in this case, we're selecting 2 marbles, right? So I could end up with 2 red. It is also possible to get 1 red and 0 red. So typically, especially with these sampling problems, we're going to go all to none. So if I write these down, I could have 0, 1, or 2 as my possible x's. Step 2 is to find the probabilities for each of those x's. So 2 red, well, probability that x is equal to 2. We've done this before. This is the probability of all. So that means for both of our events, or both of the marbles that we pulled a red marble. So this is a 3 out of 11, and then once I take that marble out, 2 out of 10 for the second marble. No need to multiply by a 2 because there's only one way for this to happen. Red and then red. I left my calculator over there. There we go. All right, so 6 divided by 110. We have 0.0545. And you could obviously leave this as a fraction in your distribution here. That's completely fine. Oh, that's the 2. Oops. And it makes sense that this is very unlikely considering we had a lot more blue marbles than red. So the next easiest one to find here is a probability of 0 for none. So probability x is equal to 0. In this case, for our 2 marbles, they're both blue, right? Or not red, however you want to write that. So the first one, this is 8 out of 11. Second one, we've taken out one of our blue marbles. We got 7 out of 10. So now this is 0.5091. And you have 2 ways that you can find this last probability. You could either add these up, right, and subtract from 1 because it all needs to sum to 1. I'm going to use that as my check though, so I'm going to go ahead and do this one. Probability x is equal to 1 by hand because it's a nice review of the section 5 stuff from part 4 as well as gives me a way to check my work. So if I want 1 red marble, that means the other marble must be blue. And this is the only one where I need to do that multiplying by 2 because I could have had red first or red second. And then the probability of the first marble is red. Well, that's 3 out of the 11. Once I take that out, the probability of the second marble is blue is 8 out of the remaining 10. So we end up with 0.4364. And you could see if we add all these up, right, they're going to sum to 1, which gives us our check in terms of this being correct. So try the next exercise on your own. Feel free to scroll to the end of that video to see if you did it correctly.